Welcome back to the Scotti-BYTE channel, and this is Scott. So I wanted to talk about virtualization in this video, and specifically I want to talk about LXD going step by step. I have the LXD 101 video, and the Scotti-BYTE channel in general focuses on LXD container virtualization. That being said, I've also reviewed LXD, LXC, Docker, and virtual machines. So a short history about virtualization. In 1999, VMware introduced the first x86 virtual machine virtualization. And so we're really looking at right about 25 years for a history of virtualization as far as x86 is concerned. Yes, I know virtualization goes back to the 1960s with IBM, but I'm talking about modern hypervisor virtualization that we think of today. So then in 2006, VMware Server was first released. And then in 2008, Linux Containers, or LXC, was released, which is what's used inside of Proxmox today. And then in 2013, Docker was released. So really, it's been a relatively short period of time, 10 years since Docker's been released. And then LXD containers were released in 2015, and LXD brings to the table a really nice API as well as a CLI to control, edit, create, modify, and manage your containers. So LXD are more efficient than virtual machines because they share a host kernel, and so that's one thing I talk about on the channel all the time. And in this video, we're going to learn how to easily install and configure LXD. So the starting point for creating a LXD server is going to be starting with some type of a bare metal machine, and I encourage you to make that a machine that has, say, at least 16 gigabytes of memory. I mean, you could start with something with 8 gigabytes of memory, but I'd not recommend it, and I'd further not recommend using a Raspberry Pi because it's just not going to have enough resources. So what you're looking at here is a screenshot that I did a while back, and it is partway through the installation of Ubuntu Server 2204. When you get to the part where you want to build the disk, say use entire disk and set this up as an LVM group, which is what you're going to be faced with when you are doing an installation of the server variant of Ubuntu 2204. Then on the next screen, it will come up with a screen somewhat like this, and you want to go down and highlight where it says Ubuntu, I guess it's IV, new to be formatted as ext4. And then on the next screen, you're going to be clicking on that and going into the edit mode on that particular volume. Once you go into the edit mode, it's going to look like this, and it's going to say I want to format this as ext4. So off to the left side, it is going to say what your max volume size is and what your current volume size is. Of course, in this screenshot, these numbers are real small, but you want to set the size here in the blank to be equivalent to whatever this max is, because by default, it'll use a very small part of the disk to create the root. And for our purposes, we want to make that take up the full size of the disk. And once you do that, it goes on to the next screen, which should look something like this. In my example, I've matched this 22.996 gigabytes to this 22.996 over here. Of course, that's really small, but this is just for illustration purposes only. You click on the save. Once you do that, it will reflect that in the very next screen, and then after that you tell it to go ahead and continue, and it'll format the disk. And the rest of the installation is pretty intuitive, but I wanted to cover this section on storage. Once your Ubuntu server is installed, you want to go ahead and SSH over to it like I have, and I have a terminal session right now on that server called my server. First thing I'm going to do is an ifconfig command, and you can see that the physical device name of my Ethernet adapter is EMP5S0. Yours may differ, but you want to make a note of that. Secondly, we have an address of 172.16.1.115, and we also want to make a note of that. So what we want to do is we want to change our EMP5S0 over to a bridge and have all the communication on this Ubuntu server operating through that bridge. So in order to do that, we do a cd over to /etc/netplan. When we get over there, we can do an ls. There may be one or more files. You can feel confident in deleting all of those files. In my particular case, I created a new file called 00-installer-config.yaml. Okay, you want to create a file and start it with a number. That's because if there's any sort of other files in this folder, it will execute them in order if you have multiple NetPlan files. But in my case, I only have one, so it's just called 00-installer. So I'm going to edit this with sudo nano 00-installer-config.yaml. And you can see here, the first thing is I have the name of my physical Ethernet device that I got from the ifconfig command. It's EMP5S0. Down here, I have DHCP4 and DHCP6 set to false, which means that the adapter itself will not gain an IP address. Rather than that, I have a new device called Bridge 0 that I'm creating, and this is a virtual switch or bridge, as I've discussed on the channel before. The interface for that is the same physical device I have above, in my case EMP5S0, and then I'm using the address that I currently have on this machine, which is 172.16.1.115. In my case, I have a subnet mask of 16. Your subnet mask will probably be 24. The next section is the routes to default section, which tells you what the default route of this server is to get off your network or out to the internet. In my case, it's 172.16.0.1, which will be the address of your router. And finally, I have some addresses here for DNS servers, and I'm using Cloudflare. If you have a local DNS on your network, feel free to use that. And I'll have all these in the show notes so that you can see what this template looks like. We do a Control-O to write the output, hit Enter to write it, and Control-X to exit the editor. Now we can do a sudo netplan space apply, and that will apply this configuration file and change our network configuration on this machine. After a few seconds, your command prompt should come back. I'm going to go ahead and clear the screen now and do another ifconfig command. And this time, you'll see that EMP5S0 down here does not have an IP address associated with it. However, the Bridge 0 device does have our address of 172.16.1.115. As we had specified, that was the address for the bridge in the NetPlan YAML file. And from now on, this server will always use the Bridge 0 device for all of its communication, which is a requirement for the way that we want to offer our LXD containers out on our main LAN. Now that we have our bridge, I'm going to go ahead and cd back to my home folder. And right now, I'm going to do a sudo snap install LXD, which will install the LXD daemon. And once it is configured and installed, we can initialize LXD. Now that LXD is installed, the next step is to initialize LXD with the command sudo LXD init. The sudo LXD init command will allow us to choose a number of options. And so first it says, would you like to use LXD clustering? My answer is no. Do you want to configure a new storage pool? The answer is yes. Name of the storage pool that you want to create, default. Name of the storage backend to use, it defaults to ZFS, and ZFS is what we want to choose. Create a new ZFS pool, the answer is yes. Would you like to use an existing empty block storage device? No, we don't have one, in which case it's going to create our ZFS storage pool as a virtual ZFS storage pool inside of a file, so we answer no. The size in gigabytes for the new loop device, it defaults to 30 gigabytes, which is not nearly large enough in order to be able to store all of our containers, as this is the space required to store all the containers we're going to use. I usually recommend that since this is a LXD server devoted to LXD, I'm going to put approximately 70% of the storage over here into the ZFS storage pool. So I'm going to say 350 gigabytes, and the reason I'm going to do that is because my disk is 500 gigabytes, and that will be just fine. Do you want to connect to a MOS or Metal as a Service server? No, we do not. Would you like to create a new local area network bridge? Yes, we do. This is the bridge to bridge containers that are not offered on our main LAN back to our main LAN. And then what should the new bridge be called? LXD BR0 is just fine, and that is the default. And what IP address should be used? And you can just say auto. And then what IPv6 address should be used, and you can say auto if that applies to your network. And would you like the LXD server to be available over the network? The answer is yes, and that's so we can manage it from products like LXD Dashboard that I've also covered on the channel. So the address to bind to LXD, the default is all. This just means it can be connected to from all Ethernet adapters. I only have one Ethernet adapter, so that's fine. And the port to use by default is 8443, and I'm going to leave that as is. Would you like stale cached images to be updated automatically? Yes, that's always a great option. And would you like to print out the YAML file in order to do this? No, I don't need to do that. And then it will go off and think for a while, and it will create the configuration, which it is just now completed. In order to be able to use LXD without the sudo command, you can put yourself in the LXD group, and I'm doing a sudo usermod-a, capital G, space LXD, space Scott, because Scott is the name of my user account. Because the LXD daemon was installed as a snap, although I had used the usermod command to add the group to my username profile, it didn't really show up after doing the new group. However, I could log off and log back in again, and I can do a groups command, and you can now see that the Scott account contains the LXD group. So what we can do at this point in time is we can do a LXC list. Yes, I know the LXD command is LXC, but LXC list, and we don't get any errors, and it comes up correctly, indicating that we can in fact do commands without the command prompt. So one of the things I could do at this point is I could say LXC launch Ubuntu colon 22.04 test, and it will create a container by downloading that container and executing it, and I will have a new container here on my system. So now at this point we can do a LXC list, and we can see our newly created container is up and running at 10.162.62.229. We can connect to that container with the command LXC exec test go into the bash shell, and we can say ping google.com, and it will be able to use that LXD BR0 to bridge on the way out. So the thing about this is that this address cannot be reached from the network because it is an address inside of the NAT network that LXD is using. So the purpose of our creating that bridge 0 device is we want to be able to present our containers out onto the main LAN, and that's the next step. So let's exit out of that test LXD container by typing the exit command. Now that we're back at our LXD server, if we simply do a LXC list, again, you can see the test device is up and running. So one of the superpowers of LXD are profiles. And if we say LXC profile list, at this point, we only have one profile, and it's called the default profile. And the purpose of the default profile is to define where the storage is, and our storage is in the default storage pool that we created with the LXD command when we did the LXD init. So we're going to create a new profile, and it's going to be called bridge profile with the command LXC profile create bridge profile. So at this point in time, it doesn't really do anything, and we're going to add some settings to it. We're going to say LXC profile device add to our bridge profile ETH0. So ETH0 is the name of the Ethernet device inside of LXD containers. Then we're going to say that the NIC type is going to be bridged, and that's going to talk to our parent bridge of bridge 0 that we created with the netplan command on this LXD server. So now we modify that, and if we do a LXC profile list, you can see that I have two profiles now, the default profile and the bridge profile. In order to create a container with the new profile, we're going to use a LXC launch Ubuntu :2204. This time we're going to call this container test2, so we'll have a second container out here. And this time we're going to say -- profile default, which is a default unless we list profiles. So in this case, we're listing the bridge profile. So we have to list both the default profile and the bridge profile. The role of the default profile is to point our container into the default ZFS storage pool, and the purpose of the bridge profile is to point our container onto our main LAN as we had defined here above. Finally, I have a switch called boot.autostart equals to true, and what that does is anytime that you boot your LXD server, it will automatically start that test2 container. So after a few moments of starting the container, we can do a LXC list, and now we have our original container called test, which was offered on the internal NAT network for LXD, a 10.162 network, whereas the test2 container is bridged to the main LAN in virtue of the bridge profile, and it points to an address on my main LAN, which is 172.16.1.178. So that system can be reached from outside of my LXD system. So therefore, what that means is it means that I can SSH from someplace on my main LAN into this container, just as though it were a standalone system. So to demonstrate this, let's do a LXC exec test2 bosh, and that will get into the shell for the test2 container. And then I'll do an add user Scott, and I'll give Scott a password. And then we'll do a usermod -AG sudo scott just to put Scott in the sudo group, and then I'll do a apt install on open ssh-server, and it says it's already installed. From my experience, it's usually a good idea to do a remove and a reinstall to refresh the keys, since it does come down from an image, and from experience it doesn't always connect the first time. So we'll go ahead and remove our OpenSSH server, and then we'll go ahead and install our OpenSSH server again. And then we'll go ahead and exit out of that shell to remind ourselves, if we do a LXC list, we have 172.16.1.178. So now if I do an SSH to 172.16.1.178, we get a fingerprint, we type in our password, and there we have an SSH session into the test2 container. And that was possible because the test2 container is bridged to the main LAN. So let's exit out of our test2 container. And again, I'll remind you, if we do a LXC list, we have test that is on the internal NAT network for LXD, not unlike the internal NAT network for a Docker container. And then we have test2 that, in virtue of the bridge profile and the bridge 0 device, is pointing out to the main LAN. So now let's go ahead and create ourselves another profile. And this profile we're going to call IoT. So we're doing LXC profile create IoT. It's now created an IoT profile. In this particular case, my IoT profile is going to point to my IoT VLAN. So I do that with the LXC profile device add IoT. ETH0 is the device inside the container. The NIC, this time NIC type equals MAC VLAN, and the parent device is still bridge 0, and it's going to use VLAN 30. Now that I've added that, let's go ahead and create a container using that new profile, and it should get an address from my IoT VLAN, and we do that with LXC launch Ubuntu :2204. This time we'll call the container test3, and we'll give it the default profile, but also the IoT profile, and we'll also set boot.autostart equals to true. Now we can do another LXC list command, and this time we have our original container called test, which is operating inside of the NAT. We have our test2, which is on our main VLAN, and now we have test3 that, in virtue of the new IoT profile, is pointing to 192.168.30.234, which is in fact an address on my IoT VLAN. So in summary, we learned the steps to installing and configuring a LXD server. We did an install on Ubuntu 2204 server instance on bare metal hardware. And then we used NetPlan to configure a software bridge. And then we installed LXD, and we performed a LXD init, and we configured about 70% of the host disk space in a ZFS virtual pool inside of a file. And then we created a LXD profile to use the software bridge to present containers with addresses on your main LAN. So then we create LXD containers using that bridging profile. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit that notification bell, and we'll see you next time.